Recording in progress. Got it.
I don't know.
Alrighty. Let us begin. All right, units 3 and 4 review. Here we go. True or false? What will the result of this Boolean expression be? False or true? And, oh, that is in the way. False or true and not true.
I swear, because I wasn't wearing my glasses. I think so.
Hello.
It's false.
Thank you very much.
It is false,
You
right?
should still be able to join if you join the Kahoot. You should still be able to join if you want. All right, well done, folks. Why is this false?
The order of operations is not and or.
Order of operations is not and or. That is correct. So false or true and not true gives us false or true and false. And happens giving us true and false, which is
False.
false. And we have false or false, which is false. Well done. So we get false from this operation.
The pilot didn't even check because it sees a false already at the left of the or, right?
If there was a true on the left of the or, it wouldn't.
Well, it's a false sort of.
It has to evaluate the right
If we're
side.
in and, then it's
False and anything is
Oh.
always false. True or anything is always true.
I just got really lucky.
All right, consider the following code. What will be output? String S1 equals new string howdy. String S2 equals new string howdy. If S1 dot equals S2, print same one. If S1 equals S2, print same two. Else print not same.
Wait. You know when Mr. Mega is dancing with Rocky, he's doing something illegal.
He did just name one now, right?
I saw an else if. I swear I saw an else if. I'm so done. It's full of sight.
No, the else is just tapped all the way past off the screen.
Mr. Mega is dancing and snapping. I know he's doing something tricky.
I'm always doing something tricky.
After that else, after the closing number.
Oh. You sound all the way down. Oh, no. I'm very upset.
All right.
Or drop shade.
Yes, this was supposed to be tricky. All right, S1 and S2 are each calling the string constructor with the same contents. Are they going to have the same reference?
No.
No, because they are both calling the constructor. This is forcing us to create two distinct string objects. Is S1 dot equal to S2?
Yes.
Yes. And as we just established, S1 is not equal to S2. What is this else tied to?
That second it.
This second if. So we will print same one, and we will also print not same because this if was false. If we only wanted to print one of these things, what we need to add?
Else.
I
We
assume
can add an else to this if statement, to the middle if.
Oh, correct. You might have maybe put the else outside the picture. I have the
I did not.
Oh,
I included all of the relevant code.
you put the else all the way off.
You didn't say that.
I'm not going to not include code that changes the way it runs.
How do we know that?
Because I'm telling you now.
Well, at least someone's carrying Lucas C for me.
All right, question 3. Consider the following code. Which of the following could be used to replace the if's condition? N1 is initialization not shown. N2 is initialization not shown. If not, N1 does not equal N2. Print A, else print B.
No. You're wrong. You're wrong.
Kidding, I'm joking.
Wait, what's the difference? It's not yellow. That's wrong. Blue. Oh, you're
What's
right.
the-
Distributive.
Wait, Mr. Mac, can you define your own Boolean kind of process?
I know it's like two variables.
No, like two.
Dancing like that.
Like, what happens when you say like not?
Yeah.
Oh, no, you.
I don't think so. Well done, folks. Is this a question about De Morgan's law?
No.
No. Why not?
Because
Not
it's
logical.
It is not using a logical operator. That is correct. This is a comparison operator. So this whole thing is the only Boolean value we're working with. So this not is not going to actually be distributed to each of these things because not of a number doesn't make any sense. What is not 7? I don't know. That doesn't make a sense. 6, 8, every number that isn't 7 is technically not 7. We can't do math with not 7. That doesn't make any sense. So the only thing that's going to get flipped by this not is this not equals. So our correct answer is n1 equals n2. There we go.
at this point, I know that Mr. Mac is always.
Oh, that's the goal. My goal is to be tricky with these.
Number one. Chester.
Consider the following code. Where is the error?
Dramatic new from not so long. Just I think we're getting. What?
Yes.
Yes. I know. It is blue. Yeah. No, it's blue. It's green. It's red. It's green. Tell me the truth. Let's go, brother. The harder Mr. Mac is dancing, the more control the
So true.
The more a trick question.
Let's go.
No.
Only the button.
Wait, let's go. Lester.
What?
How?
You're playing twice, Alex.
No, he's not.
What?
Estimate you might
He's
have.
not. He lied. He's not.
All right.
Who would play twice? Who would play twice?
I have a Boolean variable. I don't know what's initialized to. Doesn't really matter. Am I allowed to just use a single variable in the condition? Yes. As long as the value in the parentheses there evaluates to or is a Boolean, this is just fine. Am I allowed to not have curly brackets on my if statements?
Yes.
Also, yes, as long as there is only one statement inside. Here, my if statement has a print line. My else if has one statement, also a print line. Both of those are valid as long as there's only that one statement inside of them. And yes,
One line of code.
one line of code. So one thing with a semicolon. So even if you have another chunk here with a semicolon, that won't work correctly. So we have one statement, one thing can happen inside of an else or an if or an else if or whatever, without curly brackets. If we want to do more than one thing inside of an if or an else or any of those, we need curly brackets. And I don't think I'm going to have that concept on the final. I don't think it is in any of the questions, but it's useful information to have. It can save us a couple of lines of code occasionally. Yes.
What's the value of my folder? It doesn't matter.
It doesn't matter. I didn't show what it's initialized to. It could be true or false. It doesn't really matter. So that fact of we don't need curly brackets is why else if actually works the way that it does. Else if is not a special keyword in Java. Essentially what we're doing here is we're nesting an if inside of an else. This if statement is the one statement happening inside of this else, which gives us this else if functionality. If we kind of draw it out, we're chaining. Can I draw on here? If, else, with an if inside, with an else, with an if inside, and it chains like that. But since we don't need curly brackets, we can kind of collapse this to be here and have it look a little bit cleaner.
Wait, are you?
Wait, so are you saying why we don't need else? If and an else, then don't we need else?
An else is not required.
It's not
You
required.
do not need an else. You can have an if that does not have an else, your code will run just fine. You can't have an else without an if,
Okay.
but ifs can be all by themselves with absolutely no
Can
problem.
you do if and then else? So if this and then else.
Yes.
Yeah, that's how we use them.
No,
That's just a lot of
if
cock.
else if and then if else, you can't have else if or else if.
Correct.
Sorry.
Now, is this else if actually useful right now?
Not really. It's just-
Not really, because
It's not my fault.
we're testing the opposite condition of the if statement. So this would be more useful as an else. We don't need to check that condition because if this condition was false, this one's always going to be true. There's no way for that not to happen. So we don't really need this if, but it will work as it is currently written.
Ryan Hamilton.
Right. Where's the best place to put this so that it's not in the way?
Right.
Can't put it any lower, which is very frustrating. Oh, that's what I wanted. Thank you. Thanks, Windows.
Wait, we can see it on our iPad.
Yeah, you can read it on your iPad too. Consider the following code. What will be output? Int n1 equals 6 mod 10 if n1 equals 3 system dot dot print c else n1 equals 4 system dot dot print d. What will we be outputting?
No, 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 I got fooled. I got fooled. I thought that. No.
Lucas, I saw you.
Oh, no.
You got it right. Did you?
No.
No, I thought it was something else.
Oh,
I'm sorry.
I pushed the wrong one.
I'm sorry. Actually, I'm not that sorry. I'm laughing. I'm very good at tricking people.
Wait, I already
I'm
answered.
good at writing these tricky questions.
Oh, don't worry.
Let's go! No.
I didn't
Why?
think it was that one got it right.
Why will an error occur?
Because there's no if.
Because there's no if. We have an else with a condition on it. Will that work? No. Else should not have another condition on it. The only condition for an else is that this if was false. If we wanted to include this condition, we would need a second if here. Now, if we did have this if that did exist, what would we see printed?
Nothing.
Nothing.
Oh, no.
Why would we see nothing?
6 mod 10 is 6.
6 mod 10 is in fact 6.
Wait.
How many times does 10 go into 6? 0 times, which gives us a leftover of 6. If we have a bigger number on the right and a smaller on the left, the remainder is just the number on the left. So here we are. Even if there was not an error, we would not see anything printed.
He was dancing really
Oh,
well.
this was a double layered stacked
no.
trick.
I fell for
Wait,
both
even
of the
if there
tracks.
wasn't an error, we wouldn't see it.
I found if there was no error, we would not see anything printed here. Because n is neither 3 nor 4.
So no matter how much bigger the right number is in the modulus, it would just be the same.
Yeah, so no matter how much bigger the right number is than the left number, If this number does not fit into this number, we have a quotient of 0 and a remainder of the number on the left.
Oh, Christmas.
All right.
Oh, OJ.
All right. Let's look at the next question. Consider the following code. What will be output? N1 equals 10, N2 equals 4, while N2 mod N1 equals 2, N1 minus equals 4, print N1.
Oh my God.
That's so accessible.
So at the very least, Gilman will always get the right answer. Gilman gets the wrong answer. And he will go wrong. We're wrong again. No. What did you put? You put green? That's wrong. Feel betrayed.
That's my goal.
Okay. What did you get?
My goal is for feelings of betrayal throughout this Kahoot. Throughout both of these Kahoots, actually. Really just aiming for maximum tricks. Wait. All right. We fell into one of two camps, either forever loop or 10. What is N2 mod N1? 4. This is the same as the last question.
Yes.
4 mod 10
Is
is just 4, which is not equal to 2. So this loop never happens, and we print 10. Now, what if this were switched? What would our output be?
no. Wait. One more. I overtook you.
So let's run through it. What is 10? No, I'm not drawing. What is 10 mod 4?
2.
That equals 2. So we're going to say N1 mod minus equals 4. We get 6. What is 6 mod 4?
2.
That is also 2. So we're going to subtract. What is 2 mod 4?
2. 4. Oh, 2.
Yeah.
Thought I was 2.
That's right.
Yeah.
Negative 5 for
What is negative 2 mod 4?
2.
I don't actually remember how negative mods work.
I thought that. Negative 7.
The answer is 2. The answer is 2.
They're all 2.
They're all 2.
Yeah.
It's forever. All right. Somehow I came out to this ending last time. How did that happen? Yesterday I came to this actually coming to a conclusion. It doesn't. Whoops.
That's okay.
Yeah. Alrighty.
Aw, stress there.
We
love that. Stress.
Consider the following code. What will be output? Int count equals 0, while count less than 20. System.out print count times equals 4.
Oh no! Body rounds up. It rounds up becomes blue. Wait, no. Go to the air. What?
Which one of you?
What?
I can trust no one talking about.
Hey,
You know we dropped out.
round up to 1.
Yeah.
1 times 4 is
I win.
Yeah.
What are you talking about?
You got you're up next. Yeah. You're up next.
You know,
We got it.
you didn't already throwing out keywords.
16 still less than 20. So it goes to 64.
Oh, so it is 64.
Yeah, that's why it's not the red one. Exactly.
Uh-huh.
Well
done, everyone.
Hey.
We correctly identified. Why does this repeat forever?
Because 0 times anything is
Zero
0.
times anything is always 0. our count will never, ever, 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 ever change. So we will loop forever and ever with count equaling 0. So there we go. Alrighty. So the following code, what will be output? 4 int I equals 1, I less than 20. I times equals 4. Print I. What will we see?
It is because it's no.
Question.
Yeah.
All right.
All right. Why will we see what we see? I starts at 1. Oh, we're drawing. Cool. I starts at 1. Is 1 less than 20?
Yes, sir.
Yes, so we will print it. And then we will go I times equals 4, which makes
4.
4. Is 4 less than 20? Also, yes. So we will see it printed. What is 4 times 4? Correct, 16. What is that less than 20?
Yes.
Yes.
64. No.
64 is not less than 20. So we will exit the loop, showing exclusively 1, 4, and 16.
Well done. Well done.
This one was not expressly super tricky. At least the goal wasn't.
I was expecting it to be tricky. So I think very carefully.
I wasted way more time. I think it could have been up to the point.
Alrighty. Consider the following code. What will be output? String word equals I. 4 int I equals 0. I less than word dot length. I plus plus. System dot print. Word dot substring I.
Oh.
Good. It could also be blue or yellow. Hear me out. Also could be green.
Whoa.
Oh no. Oh, no.
What did I do?
What we should let you
Yeah, I got it. Let's go. Because it goes at 0, then 1 to 2. It goes kind of like backwards, and then 1 left, and then it goes 8. I feel like you want to get right. That's why I put it out.
I'll never be able to
actually.
It's actually
Because there's only one. No, we only one. We need 2.
All right.
Let's go.
What happens when we have a substring with 1 parameter? It goes until the end. So what values will I hold? I will not hold. I will not hold I will hold 0, 1. That's not what the number 1 looks like. 1 and 2. If I substring from index 0, what do I get? We'll get the whole If I substring from index 1, what do we get? And if we substring from index 2, what do we get? Which gives us a total of
Pain and suffering when you get the problem wrong.
and there we are. That's our correct answer.
Let's go.
Yes.
So
I
if
forgot
it's
to
just
answer
one
listing.
thing, then
Okay,
it
I
goes
had to
all
throw
the way to
My
the
ego is
Correct. If we substring with one element or one index, it'll start there and go just to the end of the string. So we could do the same thing if we do like I to word dot length.
What to say? What can we have?
Like doing this is the exact same thing as saying word.substring I. Both of them will go up until the end of the word.
Not chest. I cannot cheat. How do you Dude, you're losing cluster.
Question number 10. Consider the following code. What will be output? Our string word equals aardvark, while word.index of A is greater than 0. F equals word.substring 0 to word.index of A. S equals word.substring word.index of A. Word equals F plus aha plus S. What will we get? An infinite loop, aha, a hard, vaha, a hark, a hardvark, or a hard vahar.
Shout out.
Bro, I need more time than 30 seconds. I need more than 30 seconds.
Gonna be hard. I don't know.
That's me. Good.
I tried.
I'll take it as one anyway.
I checked around. I literally pulled up.
All right, well done, folks. What is word.index of A?
Zero.
0. Is that greater than or equal to 0?
Yes.
Yes. So we are currently looking at index 0. What is F going to equal?
Nothing. Empty string.
It's going to go from 0 to 0, which is an empty string. What is S going to equal?
Arc.
It's going to equal aardvark. It's going to start at that index, go to the end. Yes.
Wow. That's pretty cool.
So even here, we're not even losing the A to begin with. So even if we were trying to replace with something else, if we weren't adding more A's, even this wouldn't actually, this would cause an infinite loop no matter what. But since we are adding an aha in between F and S, we get aha, aardvark.
Should have answered faster.
And then what is the index of A?
0.
0 again. And we will just keep adding ahas forever.
Mr. Mac,
We will end up with an infinite aha hardware. So that's not good. Yes.
Where did the capital A come
Where's the what?
Capital
Capital A. That's a D. It's a poorly written D. Sorry. All right. Cool. A hard work.
I know, I can tell. I can tell. I see. So hard.
Alrighty.
I'm gonna throw.
Final question. What will be output by this code? Int I equals 5, I greater than 0, I minus minus. J equals I greater than 0, J minus minus. Print J. What do we see? Which of these number shapes?
I got confused because of the.
No, because Go contest the same day.
Why? Because I can't be in the top 5. Yes, you can. Oh. For the cloud.
All right, well done. Oh. Sam,
Why?
Sam, you're not in this class period. I mean, he's in fourth period.
I was back.
Hi, you're early.
Yeah. Early is better.
All right, well, how did we get the shape that we got? What values will I hold?
4, 3, 2, 1.
5, 4, 3, 2, 1. Can I please draw? Thank you. 5, 4, 3, 2, and 1. What values will J hold? 5, 4, 3, 2, 1. 4, 3, 2, 1. 3, 2, 1. 2, 1, and just 1. Notice we're not ever going to include 0 because we're looping greater than 0 on both of these. And we're just going to print out the value of J here. So we will see these values output. And there we have it. That's cool.
I was in second before, and I just kept on dropping.
Yes.
Oh, wait,
All right, let's look at our podium. And we have Strasser. In second place, we have.
Let's go, Rod. Let's go.
And in first place. Our runners up are Basin and Fun.
Hey.
Please come up and claim your prize.
The second. Or third.
Who wants a candy?
Yeah, who wants candy?
We're gonna have a rock paper
Rice? I don't want you.
What do you want?
You know, actually, I'm
You want candy?
Thank you so much.
Oliver, what candy do you want?
You're in here.
I want candy.
I choose a grape for Oliver.
Here's the money, like coin. You choose.
The one from last month.
All right. Everyone claim their prize.
Political support among the
Bye, Mr. Mack.
Bye, I guess.
Follow me.
Okay.
Has everyone claimed their prize?
I think Lucas should do. I think the high two.
Which one?
The good one.
Yeah.
Oh, nice. What is this?
You mean Bruno.
What, this one?
That's the correct answer. It is? Oh, never mind, that one then.
Okay, you want this one?
Oh, okay, sure. You touch that one, I guess. Michael, I've got a gift for you. Thank you, Lucas. I appreciate it.
All right. Thank you all for playing.
How can you do this?
Let's take a gander at our signed out. What the heck?
Don't like you.
What's it?
You know what's the next one? Rice? Hop the next.
City to Google live on stream.
Kind of short for a workout.
Oh my god.
Oh, it's like
It's okay, it's not as bad as last time.
I feel like it's pretty long.
Better than last time.
You have to do it
Great, you've been doing great, but.
Okay.
I mean, have you heard of the quantum BOGO?
Quantum BOGO, super efficient.
Quantum BOGO fuzz immediately guesses the password correctly.
Correct. True.
And it means
Okay. Study guide. Boolean variables, very easy. I think we got that. Relational operators. I think you guys understand those. What kinds of values can I use with relational operators?
Boolean values. Oh, anything.
Literally anything. We can compare two values very easily. Any two memory addresses, we can compare. Now, if I work with primitives, what is going to be compared when I compare the values of those memory addresses? The actual values. If I compare relational variables. We're going to compare memory addresses to each other, which are likely not going to be the same. If I give you a Boolean expression, I expect you to be able to evaluate it, as well as be able to check if another Boolean statement or Boolean statement, whatever, is equivalent to that statement. So, yeah, there's that. Just remember, while you're building if, else if, you need a specific order. What is the order for if, else ifs, and else?
If else
If, else ifs, and then else. How many else ifs can we have?
as many as you.
Literally infinity. As many as we want. So there's no limit to how many else ifs we can have. Can I have an else without an if?
No.
No, that doesn't make sense. Comparing objects. Like we said earlier, when we use equals equals, we are comparing the values at our variable's memory address, and relational operator, or not relational, reference variables at their memory address store another memory address. So if we're comparing two memory addresses, we're probably not going to get the actual comparison we want. For comparing objects, we want to use the equals method to compare contents rather than addresses. And then looping, while loops, for loops. Doing algorithms, strings. Do you guys want me to cover that? I feel like it was pretty good on the Kahoot. Anything you want me to cover in particular? Or any topics that you would like me to rehash? Cool. Alrighty, that'll be it for our time today. I will stop our recording.